Hello, madam.
Yes, sir.
My skin is shared already. Yeah.
Yes, sir. Good evening once again, sir.
Very
I'll
good.
just brief our participants about your introduction.
Okay, okay, no problem. So we can start now, yeah, or we have to wait for
Yeah,
two
we
minutes.
can start, sir.
Okay.
Uh, Sorry for the first session technical problem, participants. So now we are ready to move on to our next session. So our next resource person is Professor D. Subarna Shakya. He is a professor of computer engineering at Department of Electronics and Computer Engineering, Pulchowk Campus, Institute of Engineering, Tribhuvan University from Nepal. So he is also a visiting professor in Brown University, Rhode Island, USA. He is also a director of IT Innovation Center, Tribhuvan University, and he also served as executive director at National Information Technology Center, Government of Nepal. And also he is head of the Electronics and Computer Engineering Department and director of Center for Information Technology and chairman of Electronic and Computer Engineering Subject Committee. So he's the advisor member of National Information Technology Committee, Government of Nepal. He has delivered over 30 keynotes and invited speeches at international conferences and workshops. He has published over 150 scientific technical articles and 5 books. He has been serving as an editor, guest editor for over 15 international journals. He is the expert member of Board of Studies in South Asian University, India, and he is awarded by Nepal Education Leadership Awards and Outstanding Contribution to Education. And also, he has a World CSR Day and World Sustainability Day. He is awarded 100 Most Dedicated Professors. He is one of the 100 Most Dedicated Professors. He is a chief editor of Journal of Artificial Intelligence and Capsule Networks. He has served as a chairman technical committee and committee member in many international conferences such as Springer and IEEE related to computer science and ICT as a chairman. His keen interest in research and development of ICT, e-government system, information security for e-government system, multimedia systems, computer system simulation and modeling, cloud computing and security, software information system, and computer architecture. Thank you so much, sir, for accepting our invitation and having here today.
Thank you, madam.
Thank you, sir.
Okay.
You can share yours. Yes, sir.
Okay. Okay. Thank you very much for inviting me as a speaker to today's session. So from classic to quantum, machine learning in the area of quantum computing. So my presentation is as follows: introduction, classic machine learning recap, and quantum computing. Then after that, why do we need quantum computing in machine learning? Then quantum machine learning. Then after the comparison between classical machine learning and QML. Then after that, I talk about real life and potential of the QML. So introduction, what is machine learning? Subfield of artificial intelligence, that means that focus on the development of algorithms for decision making and pattern recognition. Computer learns automatically from past experience to enhance the performance. Core concept of machine learning is data-driven learning, that means learn pattern or make prediction with help of the large data sets. Then after that, algorithm, some step-by-step computation procedures apply to learn from specific data set, varies from problem to problem. So next is the core concept of machine learning, that means training and testing is the most important here. Label or on-label data from large data set, train and model is tested on unseen data for evaluating and generalizability of the model. Then after the workflow is data collection, pre-processing, feature engineering, model training and evaluation and deployment. So types of machine learning: supervised there, model is trained on label data, that means classification and regression. Unsupervised means model is trained on label data, clustering, anomaly detections, and reinforcement learning. That means model learn from environment on the basic of rewards and penalties. Then semi-supervised and self-supervised learning. That means learn from some label data and unlabeled data, or model learned by the generating own label of data. Application field of machine learning is healthcare, diseases detection and diagnosis. Then another is the finance, fraud detection, stock detection, robotics, that means autonomous vehicles, robotics control. Research and development is climate modeling and material science and marketing recommendation system. We can use it. And entertainment, development of games. And classic machine learning recap is that means classic machine learning refers to algorithm and method for analyzing data and making prediction without explicit programming. Then limitation are sensitive to data quantity and quality and quantity. Then after that may overfit and underfit it. Hyperparameters are not tuned correctly. Another limitation is we can training large model in computationally intensive. And in quantum computer, the
Sir,
quantum
sorry to
uh,
interrupt you.
okay, please.
Can you once verify your audio, sir? It was very disturbance. Some disturbance is coming.
Here now it's okay. Sound system. Hello.
Yes. Yes, sir.
So from there is no disturbance here. And now it's okay. My hearing my sound audio.
Yeah, we are getting, but the background, some noise, disturbance, it is with that.
There, there nothing here like right now.
No, it's some speakers or you are using any headset that.
No. I'm not using anything here.
Okay. Okay, sir. Can you be a bit louder so that it will be no problem?
Okay. The quantum machine is human-made device that follow the law of quantum mechanics. That means qubits, interferences, superposition, and entanglement is information processing. Qubits can be one state or maybe zero state or combination of two state at same time known as linear superpositions. Mathematically, to represent the qubit states, we use gate notation. Qubits state gate 0, that means gets greater or equal to transform 1 0. Then after that qubit state 1 is that means greater or equal to transforms 0 1. So qubit is represented as a linear superposition of both basis states simultaneously. Then quantum machine learning is integration of quantum algorithm with machine learning program. That means bit 0 100%, 0 or 1 in qubit 50%. That means superposition, this is this type, and qubit, that means entanglement is there. So bit, that means qubit versus bits. A bit is unit for measuring the information. In classical bits 1 empty, 0 fill means 1, that means 20 red breaks, that means 0, 20 blue breaks, that means equal to 1. That means 8 by 20 of 0 and 12 by 20 of 1. This is the quantum bits. This is the 8 and this is the trial. That's in the case of quantum bits, 50% chance of landing on 0, 50% chance of landing on 1. Now sound is okay? Audio? Principle and condition of quantum computing, superposition is there. That means classical bit can exist in one of two state, 0 or 1. In contrast, quantum bits or qubits can exist in superposition both 0 and 1 simultaneously. That means it is enabled to quantum computers to perform the multiple calculation in parallel. In the bits, that means red and blue is there. In qubits, you can combination, that means superposition. That is entanglement, means that means qubits can entangle, meaning the state of one bit is directly related to state of another. That means regardless physical distance between them changes to one qubit will instantaneously affect in the entangled partner. Then entanglement is allowed for more efficient information processing certain algorithm. This is the correct correlation of two qubits. This is another thing. Two qubits can strongly correlate with each other even if they are located light years apart. In the quantum mode, this means used in the encode program. Another is the interference in the case of constructive, another is the destructive. That means quantum computer can manipulate the probability amplitude of different computational parts. Quantum interference allow constructive or maybe destructive, already shown here. Interference between these parts influence the probability of obtaining the particular result when the qubits are measured. So another is the quantum gates. Quantum computer use quantum gates to manipulate qubits and perform operations. These gates are analogs to classic logic gates but operate on the principle of quantum mechanics. That means operator is there, so many operator, gates is there, then matrix is there. Yeah. Quantum parallelism. Now, are you hearing me, my voice clearly, or some disturbance? Hello, madam.
Sorry, your mic is a bit disturbing.
How is disturbing? Hey, Helicopter. Now,
Sir, yeah, अलि ठिक छ त्यो अलि डिस्टर्बेन्स हटाइरहेछ कि हजुर एकचोटि अनम्युट गरेर अनम्युट गर्नु न सर हुन्छ
now it's okay.
अहिले अलिक क्लियर छ सर अहिले अलिक
Yes,
क्लियर
sir.
छ
So quantum parallelism, due to the superposition, quantum computer can explore multiple possibilities simultaneously. That means this enables them to solve certain problem much faster than classical computer. That means especially for tasks like factoring large number, searching on sorted database, and simulating the quantum system. That means series computing is there, and there is the quantum computing try to all keys in parallel to single box, time efficient resource efficient. Then another is the parallel computing that has many boxes as key and try all the keys in the parallel. Time efficient, resource in that means inefficient is there. So another is the quantum coherence. That means refers to ability of qubits to maintain their superposition and entanglement properties over the certain period. That means decoherence caused by the interaction with the external environment. That means maintaining coherence is the significant challenge in the building practical quantum computer. It's the classical scattering and is the quantum scattering. Coherence is there. In the case of classical scattering, target body is environmental protons and the motion of the target body will not be changed by the scattered protons on the average. In quantum scattering, the interaction between the scattered protons and superposed target body will cause. That means thereby delocalizing the phases coherence from the target body to the whole system, rendering the interference pattern unobservable. So error correction, another part is there. In quantum computer, that means susceptible to error due to environment noise and imperfection in hardware. Implementing error codes such as quantum error correction is the crucial for preserving the integrity of quantum information and making quantum computation reliable. That means another is the quantum error correction. This is the use for quantum computing to protect quantum information from error due to the decoherence and other quantum noise. That means theorize as essential to achieve the fault tolerance quantum computing. That means it reduces the effect of noise. Faulty quantum gates, faulty quantum preparation, and another faulty measurement disallow algorithm of greater circuit depth. So next is we have QEC techniques. The CAT code, that means type of quantum error correction code is specific specifically designed for continuous variable content system, often associated with the GKP encoding schema. In this context, CAT stands for Coherence Amplitude Transmission. That means GKP cores and the CAT cores are relevant in the field of continuous variable quantum computing and quantum communication, particularly when dealing with quantum state and harmonic oscillation like electromagnetic field of mechanical or mechanical oscillation. Why do we need quantum computing in machine learning? That means, as mentioned, the limitation of the classical machine learning. The advantage of quantum to overcome the machine learning limitations are qubit receiving more information due to the superposition. Entanglement enables parallel computation, and the quantum tunneling helps escape the local minimum. Then after that, the many real world problem that needs potential in the use of computing process power and the text. Every long of problem possible to solve this classical computation include cluster and classification problem for very large data point. Then after that, find the prime factor very large number. So need for quantum analysis the quantum speed up superposition parallelism. Classical bits under 0 or 1, while qubits can represent a combination of 0 and 1. That means simultaneously due to the superposition. And that is the quantum computing process, the multiple possible parallel leading exponential speed up for the specific problem. And another is the optimization problem is here. Many in machine learning tasks like training neural networks, clustering requires solving complex information problems that can be computationally intensive. Another is the fast linear algebra operation. That is linear algebra forms the backbone of machine
Sir,
learning.
sir,
Uh,
can you leave once and rejoin again because it's a lot of disturbance. The participants are not able to hear.
yeah,
Yeah.
if you zoom, use the zoom, it's better. Yeah.
Maybe it's a network, might be network problem also. So once if you rejoin,
Okay, I will try again. Just a minute.
hello, sir. Sir.
I can start from beginning or what?
If you quickly over through, it will be better.
So I already. So now the sound voice is good.
Yes, sir.
Okay. So I already done my presentation. Why do we need quantum computing already? Yeah. Just quickly, I share my slide here. This is machine learning, core concept of machine learning already share. Yeah. Core concept of machine learning, application, a field of machine learning. Then after that, classical machine learning recap. Then quantum computing, already mentioned about this, and about quantum qubit versus bit, and principle and conditional quantum computing, superposition, entanglement, and then after that quantum interference, constructive and destructive. Then after the quantum gates, operator gates and matrix, and quantum parallelism, that means serial computing, quantum computing, and parallel computing, and quantum coherence. This is the classical scattering. This is the quantum scattering. And then after that, error correction is there, quantum error correction, and then after that, quantum error correction techniques, the CAT code. And why do we need quantum computing in machine learning? So as mentioned, the limitation of in the classical machine learning, here are some advantages of quantum to overcome the machine learning limitation. Qubits represent more information due to the superposition. That means entanglement enables parallel computation. Then after, quantum tunneling helps accept the local minima. Many real-world problems that need exponential rise in computing processing power and takes very long or almost impossible to solve. These classical computers include cluster and classification problem for very large data point. Then after that, finding the prime factor of very large number. Then another is the quantum speed up, that means superposition and parallelism. Classical bit, that means either 0 or 1, while qubits can represent the combination of 0 and 1 simultaneously due to the superposition. This enables quantum computing to process multiple possible in parallel, leading to exponential speed up for specific problem. Then another is the optimization problems. Many machine learning tasks like training neural networks or clustering require solving complex optimization problems that are computationally intensive. And another is the faster linear algebra operations. That means linear algebra forms the backbone of machine learning. Matrix inversion, eigenvalue computation exponentially faster than the classical counterpart in some scenario. The comparison between classical computing and quantum computing are basic units are bits, here qubits, parallelism, sequential and limited parallelism, here is quantum parallelism, massive parallelism, and computation power limited by the hardware as well as the efficiency, potential for the exponential speed up for some problems. And key principles are Boolean logic and the determinism, superposition, entanglement, and quantum interference. Then error rates are low, here is high, algorithm efficient for many classical problems and efficient for specific problem, that means factoring and optimization. And application are, we can use general purpose computing, web apps, and quantum chemistry, cryptography and optimization. Technology maturity are high, mature, and scalable. Still in early stage, hardware and algorithm scalability, that means easy scalability, cloud and multi-core, difficult to scale hardware and coherence issue. And the story of QML is first generation conceptual foundation 1980s to 1990. Then after that, in 1990s to early 2000, second generation quantum algorithms era. In 2000, QML framework begins here. And in the fourth generation, first implementation is there. Then after that, in the fifth generation, practical application and hybrid model is there in the 2019 to present. Quantum machine learning, that means is the interdisciplinary field at the intersection of quantum computing and machine learning. It leverages the principle of quantum machines mechanics, that means to enhance the capabilities of machine learning algorithm. That means training data is most important here, then model, then cost, then computer guidance, then update is, then after that is goes to the model also. This is the overview of the QML. Quantum machine learning, that means in machine learning, classical machine learning is there, processing method. That means in quantum machine learning, QML, that means quantum data is there, qubit and applications. In case of this is the CML, QML is there, CML plus QML. That means types of algorithm, CC, classical type and classical quantum algorithm, quantum to classical and quantum to quantum algorithm is there. This is the types of data we can use, quantum to quantum data. This is the types of algorithm. So comparison of classical EML and QML is, in EML we have input dataset D and new instant EX means process, that means a classical machine learning algorithm process the data, and output A is prediction. That means this is the machine learning case, this is the QML. Encoding quantum machine or machine learning algorithm is there, readout, then prediction. That means quantum system state preparation, unitary evolution, then after that measurement. So in the QML algorithm input, same dataset D and new instance X means additional step is encoding. Classical data is encoded into quantum state. Then quantum learning means the quantum machine learning algorithms process the encoded data. In readout, that means quantum results are extracted, measured into classical format. Output is predicted. In quantum system, describe the QML process in detail. State preparation, initializing the quantum state. Then after that, unitary evolution, applying the quantum operation to evaluate the state. That means number of buses is there, classical computer, and another is the quantum computer. This is the computation time. You can shown in the graph. Real life and potential of QML is healthcare. Problem on using classical EML. In classical EML, struggle with simulating complex molecular interaction due to the potential growth in the computation. Advantage are quantum system can simulate quantum interaction at the molecular level, helping to predict proton only in the structure. Then example is optimizing molecules for targeted treatment or prediction complex biological reactions. The answer is the cryptography and cybersecurity. Problem on using classical EML. That means in classical EML cannot efficiently break certain cryptographic system or detect cyber threats hidden in the large data set. Advantages are quantum algorithm can solve problem like factoring large number of, that means RSA encryption or pattern detection in high dimension data. The example are strengthening cryptographic method or detecting anomalies in the cybersecurity logs. Third one is the climate modeling and weather prediction. Problems using classical EML are classical EML models are limited in handling the chaotic and complex nature of the climate system. Advantages are quantum system model this system with higher precision by simulating interaction at smaller scale. That means example are enhancing the climate change model or improving the long-term weather prediction. So quantum machine learning for disease prediction, already done some Python programming here. How we can do that disease prediction? This is the another one example. The quantum machine learning for disease prediction is explanation here, and in the healthcare data set, synthetical data representing age and cholesterol level. That means disease. If age is 50, greater than 50, cholesterol is greater than 200, otherwise zero healthy. And quantum circuit encodes the health data to quantum state using angle embedding. That means, and then another is the uses strongly entangled layer of the Variational quantum processing. Output of a single value, that expected value, which is mapped to the prediction. And training in this particular case, binary cross entropy loss is used to minimize the classification errors, optimize the using gradient descent. In the testing, the trained quantum model predicts the disease status for unseen data. test data. Then after accuracy is calculated and prediction are visualized. The output is accuracy. That means shows the model's performance on the data set. And visualization means scattered plot showing prediction and ground truth. And this is my presentation. Yeah. And another is the my one of the student is going to present his thesis also. We have to wait for 2 minutes. Ritu, तिमीले पनि गरे हुन्छ है? Ritu, are you there?
Yes, sir. Yes, I'm there.
Okay. Yeah. You can also share. I stop my share here. Okay.
Sure, sir.
Okay. Okay. तिमी एउटा गर. This is related to my quantum computing. So.
I request host to make me a presenter in this conversation.
Yes, sure. Just a second. You can present now.
Thank you, ma'am.
Are you able to share your screen?
I'm trying to. Just a second, ma'am.
Okay.
We are just not using such tools so that.
Yes, I understand this platform.
That's why anything, no problem.
Yeah.
No problem.
Is it visible?
Yes.
Okay, yeah.
Okay. Good evening, everybody present here. Respected resource person, Professor Dr. Subarna Shakya, the host, and every participant present in this workshop. I am Ritu Vajracharya from Department of
Full screen गर्ने कि full screen?
Full screen. Full screen
Yes.
makes up often say that. Is it full screen?
Not yet.
Not yet. Keyword. Is it visible now? Full screen?
Yes. It is fine now.
Thank you. Thank you so much. I am Ritu Vajracharya from Department of Electronics and Computer Engineering, Pulchok Campus, Nepal. And today my presentation title is Task Scheduling Optimization in the Cloud Using Quantum Annealing. And I am very happy that Dr. Subarna Sakya sir has provided me this opportunity to present this presentation here. So my slide overview goes like this. It has basic introduction, objective of this thesis title, and scope and application of this thesis, along with the result and analysis that I have received from this research, and the conclusion. So going through basic introduction, we all know that cloud computing is very emerging technology nowadays. It provides the services anywhere, any place, and at any time. And here, through cloud, we use infrastructure as a service, software as a service, and platform as a service. However, though cloud computing has made technology more easy, but there are many complexities related to cloud computing, as it consists of multiple number of users and multiple processing elements that perform certain tasks. So one of the major problem that we face in cloud computing is load balancing problem, because there are many virtual machines, there are many processing elements and many tasks that has to be completed with certain period of time. So load balancing problem can be solved using a proper task scheduling mechanism, which helps to schedule the tasks, optimal task schedule, and makes the load balance much more easier. And also that task scheduling is an optimization process which has many constraints, and it is a NP-hard problem. So one of the method that can harness task scheduling is quantum annealing along with task scheduling algorithm. So jumping to next slide, it is about the quantum computing. So basically, what we hear about quantum computing is that quantum makes everything easy. Quantum makes everything complete the work in small time span, short time span, and we know that quantum computing is new paradigm of technology that uses qubits which can exist in superposition state. As Subarna sir has also explained us about superposition state, where the bits can occupy either 0 or 1 or both states. It ultimately makes the uh, execution faster. And also one of the other important property of quantum computing is quantum entanglement, which where the qubits become correlated, resulting the state of one affecting the other regardless of the distance between them. So the change in one bit makes the change in other bit, and this is how quantum computing has evolved so far. So basically, as per we have discussed, or we have, as per Dr. Subarna Sakya has mentioned, there are two different strategies for quantum computation. One is gate-based quantum computation. Uh, One is gate-based quantum computation, where different quantum gates are used, and other is the quantum annealing. So in this particular research, I have used quantum annealing technique to schedule tasks among different processing elements that has been used in cloud computing environment. So the basic difference between gate-based quantum computing and quantum annealing is that gate-based quantum computing is aimed to solve wide range of problems through quantum gates, and it is mostly used for problems like cloud security or error correction, or different kind of uh, algorithm that can be used for error correction. But quantum annealing is widely used for combinatorial optimization problem. So as task scheduling is one of the combinatorial optimization problem, we have chosen quantum annealing as one of the approach to schedule tasks in cloud computing system. So quantum annealing is based on quantum tunneling and adiabatic quantum computation. So, talking about quantum annealing and adiabatic quantum computation, what we find is that the qubit has a very strange nature. The particles in quantum computation has very strange nature that is known as wave-like nature. So, in classical computation, what we assume that if this barrier has energy greater than the particle in this left hand side, that is the particle that has less energy than the barrier, then it cannot surpass it according to classical computation. But in quantum computation, what it provides the definition is that though particles exhibit less energy than this barrier, it has ability to surpass this barrier, but it has some delegation in the energy on the other side of barrier. So this is known as quantum tunneling, and this quantum tunneling is the major thing that supports quantum annealing. And similarly, in this figure, for example, we have to find out the global minima in this problem. So according to classical approach, this particle has to jump every path as far as possible, and it can provide each and every local minimum. But according to quantum tunneling, it can surpass through this barrier. So at the final range, we can find the global solution, global minima, by surpassing all local minima. So due to this reason, quantum annealing provides faster solution than classical methods. So according to quantum annealing, the system always needs to be in the lowest energy state, which is known as the ground state. So due to wave-like nature of qubits, it can surpass the barrier with some delegation in energy. So the particles found on other side of barrier is found in other side of barrier, even if the energy of the barrier is higher than that of the particle. So after the adiabatic evolution, the solution is found to global minima. So this is about quantum annealing and adiabatic quantum computation. So quantum computation benefits has been mentioned by our sir too, but there are certain algorithms such as Shor's algorithm, Grover's algorithm, quantum algorithm for appointment scheduling, quantum annealing for deep space network scheduling, and these are some research papers too. So according to Shor's algorithm, it can decompose large number of prime factors which can transfer classical NP problem into P problem. So this has resulted in computation exponentially faster use of quantum. Similarly, Grover's algorithm is also one of the quantum algorithm that searches the data from disordered databases with polynomial acceleration. Likewise, according to one research paper, quantum algorithm that has been used for appointments scheduling shows that embedding quantum algorithms for scheduling the appointment, the communication complexity is OK square root k, which is better than classical one with O k to the power 2 to the power k. So where k is the total number of users that uses the system. Similarly, it can be used for deep space network scheduling also. So scope and application where quantum annealing specifically can be used are cloud computing, where in this specific area I have used for task scheduling. Similarly, it can be used for high performance computing. Similarly, it can be used for supply chain management, routine management, and traffic route management. So what actually happens in task scheduling is in cloud is that it is basically a combinatorial optimization problem. So it has to satisfy many constraints. The constraints may be satisfying deadline or making the make span as far as possible, and many more. And similarly, it consists of various processing units as resources that needs to be distributed among requested job. So this is a very complex thing that has to be maintained in cloud computing. So by using quantum in task scheduling can help load balancing in cloud computing system. So problem statement, as per we have discussed before, so simulated annealing used thermal jump from this local minima to this maxima and again to global minima, but quantum annealing use particle wave nature that surpasses this maxima and surpasses through barrier which finds the global minima, and it ensures that the solution that we have found is optimal. So, task scheduling using quantum annealing. How can we use quantum annealing? So, there are many platforms that provides quantum computation and quantum computers. One of them is D-Wave quantum computer. Another, we have heard about IBM quantum, used for gate-based system, but D-Wave quantum computer is specifically used for quantum annealing. So here QA can, here in this specific research, I have used D-Wave quantum computer provided by D-Wave system located in California. Similarly, the job swap algorithm with qubits. Jobs of algorithm with qubits has been used for scheduling purpose, and here our objective is to minimize the make span, that is total response time, and the constraint includes that one task should reside in one processing unit, deadline should be satisfied, and a precedence constraint, that is if we define precedence among the task, then we have to maintain the precedence. We cannot let any other process to execute before the one that has higher precedence. So D-Wave quantum annealing system is just like this. So you are provided one ocean software through online. So you can have many facilities through ocean software, such as graph mapping, constant compilation, a new mapping method, problem suitable for QPU, simulated annealing. APIs are also provided there, and hybrid algorithms, hybrid solvers are also provided there. And how it works is that we use software interface through our computer, and we provide constraints, we provide our objective function over there, and through this quantum annealing hardware, it provides solutions. So how QA workflow, how does QA work? So this is a basic workflow, how D-Wave computer works. So basically we have to formulate QBO model. So what QBO model is, it stands for quadratic unconstrained binary optimization model. So in here we represent our processing units, we represent our time units, we represent our virtual machines in cloud computation in different constraints. So how we have done is that in QA, we have defined the problem first. After problem formulation, we have formulated through mathematical model with optimization problem. Similarly, that mathematical model has been mapped to QBO provided by D-Wave, and we have converted QBO into quantum annealing problem. Finally, D-Wave system provide that quantum annealing problem to annealer and provide us the solutions. So objective functions and constraints that we have used, I have also already told before too. So objective function is to minimize the make span with respect to the constraints, such as only one task in particular machine. All tasks should be completed on the given deadline. So deadline is also given there. And this deadline is mapped to QBO, and there is a precedence constraint and there is a make span constraint. So resources that I have used for my research are D-Wave Ocean SDK provided by D-Wave system. Similarly, D-Wave Quantum Annealer that is also provided by D-Wave system, Python, and Leap IDE that is a software as a service provided by D-Wave system, and hybrid solver. This hybrid solver has been used because I am using job swap scheduling algorithm along with quantum. So under hybrid solver, I have used constraint satisfaction problem. So these are the resources that I have used. And according to resource result, for total 8 jobs with 5 processing units, total completion time is 65 millisecond. Similarly, make span provided is 213 millisecond, and model building time is, this time has been given for constraint satisfaction and model building. Similarly, solver call time, from this is the time that has been requested from here Nepal to D-Wave system, and this is the total runtime. So this is a total analysis where higher the number of jobs, but the make span is uh, comparatively lower than other algorithms. So for easier comparison, I have compared these are the schedules that has been provided from DWave system, where these are 5 jobs and 8 machines. Similarly, 5 jobs, 5 machines. Similarly, 5 jobs, 5 machines. So these are the schedules that has been provided by DWave system. And for comparison, I have used different algorithms too. So here, here blue for 40 jobs and 100 jobs. PSO stands for Particle Swarm Optimization Algorithm, which is one of the heuristic algorithm that has been used for task scheduling, and QA stands for quantum annealing. So from this chart, we can find that the total make span for PSO for 40 jobs is 2,562. Similarly, for 100 jobs is 2,432. But with quantum annealing, same number of uh, machine and same number of job, the make span is smaller. So throughput is also better and completion time is also better through quantum annealing. So for conclusion, I would like to say that load balancing and optimal resource allocation are basic requirement for sustaining cloud computation and every other computation. And task scheduling is a vital role, plays a vital role in making the load balancing more optimal and providing more optimal solutions. So if we use quantum annealing for optimization problems like task scheduling, it would be very efficient because it provides reduction in CPU waste time and it enhances the performance too. Thank you so much. This is all about my presentation. This is all about my presentation, ma'am. I would like to conclude here. Thank you.
Thank you so much. There's just one question. Can you take?
So some question is there. How can we access D-Wave quantum computing? Is it online tools like?
Thank you so much for your question. Yes, it is online tool. So I would like to share once again. So is it visible?
Yes.
Now,
So yes, D-Wave system provides us online platform. So this is https cloud.dwavesys.com,
Okay.
and here you can have your email address and login. So particularly, I used a virtual private network for my thesis research, but I think it is available in India. So when you log in, you are provided many more. Now my location does not support its SS because
Okay. Okay.
due to location problem.
so the another is the can you ping that URL here?
Yeah, sure.
Of course.
Sure.
It's
I'll
not.
provide the URL.
Yeah, of course. You can provide them. Yeah, no. So
Thank you.
actually,
Thank you so much, sir, for your time
thank
and
you very much, Dr. Silpa Reddy. Thank you very much for
yes.
giving this opportunity. And Ritu Bajachari now she is working in lecture in Kathmandu Engineering College, applied to Tribhuvan
Okay.
University. Okay.
Yeah. So you are actually working on the same area, so it is very nice to hear from
That's why
the
I invite.
colleague.
That's why I
Yeah.
invite my scholars. Yeah,
Yeah.
that's why.
Thank you. Thank you so much, Ritu.
Thank you. Thank you so much, ma'am. Thank you, sir.
Thank you.
Thank you, sir. We can leave end the session. Can we end the session?
Thank you very much. Thank you very much, all of
Thank
you,
you so
for participating in this session, especially. Ritu, and Madam Silpa Reddy. Thank you.
Thank you.
Thank you so much, Subarna sir. Thank you, Shilpa ma'am. And thank you all the participants for your participations. I would like to leave the conversation here. Thank you so much.
Yeah, thank you. You can.
Okay, thank you. Thank you. Lakshmi.
Participants, please fill up the feedback form. We can end the session for today. We'll see you again tomorrow. Please fill up the feedback form. Thank you.